going to practice solving equations with reasoning. The goal is not just to get answers. The goal is to look at the structure of each equation and ask, what would make both sides equal? First, 382 plus 49 is equal to x plus 380. Notice that 382 is 2 more than 380. So this left side has 380 plus 2 plus 49. And that should be equal to x plus 380. This left side is once again 380 plus 51. And once again, that should still be equal to x plus 380. So x is going to be equal to 51. We could double check this. 382 plus 49 is 431. And 51 plus 380 is also 431. So the equation is true. Next, 7 times x plus 5 is equal to 7 times 38. Both sides are 7 times something, so the quantities being multiplied by 7 must match. That means x plus 5 is equal to 38. That will give us that x is equal to 33, since 33 plus 5 is equal to 38. Next, let's do 12 times 84 is equal to 2 times 84 plus a. The left side is 12 groups of 84. The right side already has 2 groups of 84 plus a. To get 12 groups of 84, we need 10 more groups of 84. That means a should be equal to 10 groups of 84. So a is equal to 10 times 84. That gives us that a is equal to 840. That is the value that would make this equation true. Next, let's look at one with fractions. 5/16 plus 2/3 is equal to 2x plus 5/16. Both sides have 5/16. That tells us that 2/3 is equal to 2x. We can compare what's left. That means x is half of 2/3. Half of 2/3 is 1/3. So 1/3 is equal to x. Next, 17 is equal to 17 times x minus 2. The right side is 17 times something. For it to equal 17, then the something must be 1. So we have that x minus 2 is equal to 1. That would give us that x is equal to 3. That value would make this equation true. Let's look at one more. 4 times x minus 19 is equal to 8. One thing we may need to notice for this one is that 8 is 4 times 2. So we have 4 times x minus 19 is equal to 4 times 2. That tells us that x minus 19 needs to be equal to 2. So x is 21, since 21 minus 19 is equal to 2. Let's pause and notice what we did. We are not just applying one memorized rule to every equation. We looked for structure. We noticed common parts on both sides. We noticed equal groups. We used the meaning of operations. This is exactly the kind of flexible thinking we want students to develop. As future elementary teachers, you can encourage students by asking questions like, what do both sides have in common? What is missing? What would make the two sides equal? What does this side mean? Can we check the solution? These questions help students see equations as meaningful relationships. Solving equations is about finding the value that makes the equations true, and reasoning from structure can often make the solution clear.